Hey everyone, this is Lucas Bagno, an investor at Village Global, and I'm here with my co-host Ian Cinnamon. Welcome to Solarpunk.
In this podcast, we cover topics related to space and defense and discuss how technology can contribute to a better and safer world.
Hey everybody, welcome to another episode of Village Global Solarpunk. We could not be more excited to welcome AJ Piplica today on the show. AJ is the founder and CEO of Hermeus, where he leads a team focused on radically accelerating air travel through the development of hypersonic aircraft. Prior to founding Hermeus, AJ served as the CEO of Generation Orbit, where he led the inception and development of the X-60A, an Air Force hypersonic X-plane. He has a strong background in aerospace systems design, including spacecraft, launch vehicles, and hypersonic aircraft. AJ, welcome to the show.
Thanks so much, guys. Pleasure to be here.
Awesome. So I thought that maybe we could kick things off by talking a little bit more about Hermeus and what is the future that you and the company are enabling?
Sure. So we started the company back in 2018 with the big picture, long-term vision of radically accelerating air travel. So, if you look back in history, it's been a long time since we've changed the speed at which we move around the planet. Over 50 years, almost 60 or 70 at this point. And that leaves an immense amount of growth from both a social and economic standpoint on the table that really hasn't been harvested and unlocked. And being able to not only accelerate transportation at a local level, but being able to do it at a global level is kind of the full mission that we're going after here at Hermeus in the long term.
AJ, help us understand why does that matter? Like, why should we care about moving at that faster rate of speed?
Yeah, so if you look back in history, pretty much every time there's been an acceleration of a transportation network, it's always been associated with significant social and economic growth. So you look back at when Rome built out their roads network, it was a military project. When we switched from sail power to steam power in marine shipping, when China built out their high-speed rail network in the 20th century, each of those instances were accompanied by multiple single-digit percentage point growth in GDP of the affected regions. And that really speaks to the impact that the speed of transportation or barriers to people and goods moving around, the impact that has on us as a society. And like I said, we have kind of become accustomed to the world moving at 8/10 the speed of sound, essentially. We haven't had a speed up of this magnitude in quite some time. We've kind of looked at, okay, what does this actually mean at the end of the day when all the numbers play out? And it's something that's, something crazy. About 2 percentage points of GDP growth at the global stage. So that's like $4 trillion a year of new growth that doesn't exist today. It's not like zero sum where you're growing to some places, and then you're shrinking others. This is new growth that we have to kind of keep finding ways to unlock. Like fundamentally, at the end of the day, it really comes down to face-to-face interaction between human beings. I think most of us have seen throughout the course of the pandemic just how important and valuable face-to-face communication is, and that's true for economic reasons, and it's true for social reasons. So, when I, that like $4 trillion a year is a pretty staggering number. It's maybe too big to really understand the magnitude of, but to put it in perspective, that amount of growth would pay for decarbonizing all of aviation 8 times over in 1 year. So that's kind of, the pot of gold at the end of the rainbow that, that really motivates us here is to unlock that latent potential to humanity that we've been sitting on a gold mine of for a long time, and it's been kind of really held back by the fact that we move around the world at the pace that we do today.
So, AJ, I buy it. I buy exactly what you're pitching. You're not the only one to think this way, right? We've seen Boom Supersonic, Exosonic, Hermeus, several others. There's a lot of buzz. Why do you think, one, the timing is now? Like, why has this all happened just over the last couple of years? And is there room for everyone, or is there going to be consolidation? What does this look like?
Sure. So let me answer the kind of why now question first. So, when we started the company back in 18, there are kind of 3 things that we really saw that just screamed to us, now is the time to do this. The first is that the technology, to build these kinds of high-speed aircraft exists and is mature enough today, at least at the component level, to start trying. We don't need to invent new propulsion cycles. We don't need to invent new materials. All of those things have existed. I mean, turbojets have been around since the 1950s, as have ramjets. We no longer need to smuggle in titanium from the USSR like we did in the SR-71 days. So, all of that being kind of significantly more available today, and you pair that with modern kind of computational capabilities, both from like a hardware standpoint as well as a software standpoint, along with additive manufacturing. Now you've got all these pieces to the puzzle where, when you kind of pair a modern means of developing complex systems that's very hardware focused, not purely analytical, but leverages those analytical capabilities to iterate faster. Now you can turn around a vehicle design in, a handful of years, where, probably for the past few decades, it's generally taken, about a decade or so to do it. So, I think that the pace of development in aerospace, this isn't just, the high speed mobility world. I think it's true in the launch world, the satellite world, eVTOL, you name it. I mean, we're in this crazy renaissance period in aerospace right now. People used to ask me, like, what decade do you wish you would be, living and working in as an aerospace engineer? And, a couple of years ago, I probably would have told you the 1950s. But it's now. It is the 2020s, and we've got an immense opportunity here to really kind of come in and change the way that things are done. The other kind of two things that drove us at the time were the defense applications for the technology. At least when you're kind of up at these speeds around Mach 4, Mach 5, there are some really critical national security applications for both the U.S. and their allied partners that those types of reusable high-speed aircraft systems can solve. And that for us is kind of the key to unlocking the financial challenges associated with this vision that we're trying to execute on, which is maybe a little heretical for me as an engineer to say that the technology challenges are hard, the financial ones are harder. And without intermediate markets to build kind of an incremental business on top of that has a strong growing financial foundation, it's incredibly difficult to kind of achieve that long-term goal. So the defense applications are pretty key here in making that happen. And then of course the availability of private capital, especially over the past few years, has really, I think, opened up an immense amount of opportunity for people willing to take the risk and essentially jump off a cliff and try to build an airplane together on the way down. And you touched on a number of different players in the space today, and you'd asked kind of is there room for everybody at the end of the day? So on the commercial side, the future I see is where the amount of money that you pay to fly on an airplane from one place on the globe to another, is no longer going to be kind of differentiated based purely on comfort, like the way it is today. Essentially, everybody moves at the same speed, and you pay more for comfort, more space. In the future, there's going to be another metric that kind of provides differentiation in product offerings for airlines, and that'll be speed. And I think it's actually going to go in both directions. You'll have high-speed aircraft available to you, to where a supersonic aircraft may be the price of maybe a high-end premium economy, and a hypersonic aircraft may be near business class, something like that. And you're getting there faster, you're paying a little bit more for still a comfortable experience, but not a lay flat seat. And then on the other end of the spectrum, as you see kind of the continued iteration on efficiency for aircraft, especially as electrification starts to come into the market and other forms of propulsion, say hydrogen or fuel cells or things like that, I think you're actually going to see aircraft fly slower. Especially as electric aircraft start to come in for regional ranges. But even for some of these longer range, crossing ocean type flights, I think the electric aircraft are going to fly quite a bit slower, and they may be less expensive. So now speed becomes a major differentiator in the product market, or in kind of the product mix for airlines, and people can take a range of different strategies for how they want to approach that. So I certainly see there being a wide range of room for a number of different players when the kind of commercial piece gets there. The trick is who finds a way to actually get there, primarily from a financial standpoint.
Totally. And AJ, I would love to double click on something that you said a while back, which is both the military and the commercial use cases. So I was wondering if you could double click where you see the potential for innovation in new aircraft in each of them, and how do you, as a founder, think about the balance of pursuing both commercial and government opportunities for Hermeus at the same time?
Sure. So I'll start with the commercial. I think it's actually like quite obvious. We actually used to have a slide in our pitch decks that kind of talked about the commercial opportunity here, and everybody kept having us skip it because it was so blatantly obvious how big the market is there. So we actually took it out. But that kind of gives us our guiding light for our vision and the way that we make decisions about what technologies to pursue and so forth. But while the commercial market is the reason that we started the company at the very beginning, I don't think we get there successfully if we aren't successful in solving some of these national security challenges along the way for a range of different reasons. Some kind of internal to the company, like having a strong, growing business that can actually finance getting to the commercial stage, but also the global geopolitical situation that we have right now can really, I think, be affected massively positively by bringing these types of capabilities to bear. From a technology perspective, there's obviously quite a bit of risk. We'd be naive to think we can go build a 20-passenger Mach 5 aircraft right off the bat here. There's a lot of things that have to be proven out. So, we laid out this strategy that essentially kind of took an incremental approach to de-risking the technology. And in doing so, an incremental approach to de-risking the business case as well. So the first aircraft that we're building is called Quarter Horse. It's a pretty small autonomous aircraft designed really to do two things: to get up to high speed, Mach 4 to 5, and be reusable. So that's something that hasn't been done before. It'll break the first airspeed record in almost 50 years. But for us, it allows us to get up to these kinds of conditions reliably and get back. And that kind of starts to touch on some of the defense applications in terms of hypersonic flight testing. It's an area where the United States is arguably behind some other countries in terms of our cadence of flight testing in these types of high speed, high temperature conditions. I think we've flown like an order of magnitude fewer flight tests than China has over the past 5 years. Part of the big reason for that is because of the cost that's associated with that. Most of the hypersonic flight testing that's been done in the United States to date has been based on expendable systems and especially expendable rocket boosters. So I think the going rate for just getting data back from Mach 5 is like $5 to $10 million a flight, and that may be only for a few seconds of data. So if we're able to bring reusability to that game, now not only are you reducing the cost, but you're also increasing the frequency of flight testing that can occur, and you're really starting to generate the data that's necessary to get to the next later stages of developing these kinds of hypersonic systems. So that's kind of an initial piece of defense applicability for the technology. But from an operational standpoint, the next step for us on the technology roadmap is to get to an aircraft that we call Dark Horse that starts to take on some of the high speed, long duration elements of the problem. And with a hypersonic aircraft that can cruise around for a while, come back, lands, and operate again. Now you're starting to get into some of the real operational utility of hypersonic aircraft from a military perspective. I can't speak too much to the specifics, although you can kind of let your imagination run a little wild. Obviously, the SR-71 type mission is a pretty kind of standard use case for high-speed aircraft. But there's a range of other things that can be done as you start really looking at kind of what the next 5-10 years of modernization in the defense world are going to bring about in terms of network systems operating in contested environments, especially when you're looking at areas of responsibility like the Indo-Pacific that are characterized by very long ranges of open water. It's difficult to really do anything quickly over long ranges without moving fast. So that's where we see kind of the real military utility in what we're building. And I think at the end of the day, hypersonic aircraft are really going to be a kind of a damping force when it comes to geopolitical competition. In that really they're going to be providing better and better information faster and faster to decision makers. Of course, layered within very networked and AI enabled battle space. But the quality of decision making that can be made at speed is really kind of what drives how what prevents conflicts first, and then of course if you do end up in one, being able to be successful in those types of campaigns is also driven that way as well. So obviously space is a major element of how future wars will be fought, and space is not always available to you in a contested environment. So being able to put things where you need them, when you need them, very quickly is really where the airborne piece of the puzzle comes in. So and then downstream when it comes to Halcyon, which is our passenger aircraft, there are obviously military applications to that as well from personnel and logistics standpoint. So but at the end of the day, we're really trying to align both the near-term defense applications for the technology with the long-term commercial applications, so that we're kind of building the right technology to get there at the end of the day on the commercial side, and both from a technical and a financial standpoint.
Amazing overview of the future. To take us a little bit to the past and double click on something that you talked about, I'd love to go deeper on the incredible legacy of the aerospace industry, right? New aircraft were once one of the crown jewels of American innovation. We had Lockheed's Skunk Works, the Concorde, the Blackbird, et cetera, et cetera. So from your perspective, AJ, what happened? And why does it feel, or why has it felt for so long that we've been stuck in time for such a long period of time?
Yeah, it's a really interesting question. And I wish we had some video here, because there's a fantastic visual that illustrates this incredibly well. There's a piece of art at the Pentagon that essentially is a timeline with every new aircraft development on its at scale, the scale of the aircraft over time, starts in the essentially later stages of World War I and presses forward into World War II. And when you get to the late 40s, 50s, there's just an immense density of new aircraft that are being built and commissioned, and that continues throughout the Cold War, but eventually starts to taper off. And by the time you get to the 21st century, you have a new aircraft maybe every few years if you're lucky. And part of that is the peace dividend coming out of the Cold War, but I think a really stronger driver of the kind of reduction in our ability to iterate in development has come from the way that the defense world works. It is incredibly kind of entrenched in its incumbency. The big primes are there. They're there for a reason. They can do some really incredible things. But the way that the incentive structure is set up is not necessarily to iterate at high speed through new capabilities. It's really focused on selling a big program and then sustaining it over the course of 70 to 80 years. Like take the F-35 program, for example. And I think it made it much more difficult for us to modernize the DoD, and not just in aircraft. This happens in other places as well. But it creates an immense opportunity for new entrants to start coming in and bringing kind of a new means of developing complex systems that's very hardware focused, that really pairs hardware development with modern modeling and simulation tools, to the point where we're seeing lots of new aircraft on a regular basis. Obviously, the certification and testing regimes that are required to deliver an operational aircraft are quite stringent. I think you see that even in the space world. But notwithstanding, we're not even kind of building experimental aircraft at the rate that we used to. So, I mean, and you can see kind of a similar trend in the consolidation of defense primes over the past 20, 25 years or so, to the point where now there's a handful. You kind of count them on a hand and a half. And I think going forward, you're going to see more companies pop up and be successful in delivering defense capabilities that are kind of more specialized, more nuanced, versus these big primes that are amalgamations of all sorts of different things. So I think you'll see companies building hypersonic aircraft, for example, building autonomous boats, building all sorts of different things, and maybe a little bit less of the amalgamated defense prime that builds everything from mines and bullets to buildings and Humvees and aircraft. So yeah, I think it's an immense opportunity that we have today, and also like an immense kind of responsibility at the end of the day too. That was one of the things that myself and my co-founders really kind of felt as we put the company together and got started. It was clear to us that there's immense amount of defense modernization that needs to happen, and really not enough people being willing to take the risk to go and do it. So that's certainly a responsibility that we carry on our shoulders every single day, and it's really strong motivating factor for us as we press through what we're doing.
So AJ, you hinted at this throughout kind of some of the points that you talked about before, but there's two common thoughts when it comes to building a new aircraft and bringing it to market. One, it takes $1 billion to actually do all of the work to develop it and certify it. And two, it takes about 10 years. So would love your response. Are both of those accurate? And then specifically for you at Hermeus, how do you think about that?
Sure. So I would say yes and no. I think if you're talking about a certified passenger aircraft through Part 25 at the FAA, $1 billion is probably about the right number. I think that's around what it took Gulfstream to do its most recent iteration of it's G700 or 800, whatever it is they're on today. So I don't think that dollar number is particularly far off. 10 years, I think is a bit long. I think you can do it quite a bit faster than that if you're prepared in the right way. But, for a company like us, or really anybody kind of starting out, like you're not going to go raise $1 billion of private capital to develop a new aircraft and pour all that money in before you're getting to revenue. And that's really where I think the kind of key is to this whole thing is not how much does it cost necessarily. Because I think Boom has even come out and said it's going to cost us $8 billion. I wouldn't be surprised if it did at the end of the day. Not that it has to, but it certainly can. The question is, where does all that money come from? And for us, it comes from kind of a development strategy that has multiple S curves of growth in it, where at each stage of technical de-risking, you're building a product that's solving a really important set of challenges for customers. So much in the way that SpaceX did, I think it's going to cost billions and billions of dollars to put a person on Mars, but they didn't try to raise all that money privately. They have, at each stage of de-risking the technology to get there, they found really important problems to solve for customers, and have built a really good business along the way. So Falcon 1, Falcon 9, Dragon, now and Starship and Starlink, each of those things are kind of dual use in terms of demonstrating the technology necessary to go to Mars, as well as building the financial foundation to do so. So it's kind of the same thing for us with quarter horse. Take a step in technology, get up to Mach 5 and get back, and also solve a problem, a really important challenge for customers on the hypersonic flight test side, and build the first S curve in the business. Get to Dark Horse, do the same thing. Get to Halcyon, do the same thing, and continue. But it's the key to all of that is ensuring that kind of the revenues that a company is generating with the technical de-risking that it's doing are growing ahead of the amount of capital that it needs to bring in at the end of the day. So we're still going to have a ton of private capital to raise, but we'll be able to do it on top of a steady and recurring revenue stream that allows the company to grow commensurately.
I think that overview of one, financing in general, but also your plan is very illuminating. So thank you for explaining that. To your point, very hard to go raise $1 billion up front, though you've raised $100 million up front, at least according to the last announced fundraising round. That's an incredible feat. So first, congratulations, not because fundraising is a milestone, but because that will enable you to kind of get to those first several S curves. Now, when you think about your ability to go raise that large sum of capital, do you think that if you were to start Hermeus today, where the markets are in a slightly different place than they were when you got your last funding, do you think it would be possible? Like, how much of starting a company, a deep tech hardware company like this, has to do with market conditions versus just timing the technology and kind of market demand correctly?
They're inexorably coupled. I think. So to answer your question directly, if we started the company today, I think we would still be successful in raising seed rounds and even possibly Series A. But I think the maybe more interesting question was like, if you needed to raise your Series B, $100 million Series B today, do you think the company would be successful? That is a much more more difficult question to say. Yeah, absolutely. So market conditions and timing are immensely important, and some things you can kind of foresee and plan for, and obviously there's plenty of uncertainty, and some things you just can't control. But in the defense world specifically, which is kind of where we spend most of our time from a customer perspective here in the near term, I do think the defense world is going to be a little bit insulated from much of the kind of market movement that we're seeing today, given obviously like consumer focused companies are going to have a very difficult time. I think defense focused companies, we already have a difficult time. I don't think it gets that much more difficult, but like maybe it's now as difficult as it is for other consumer focused companies. And it's difficult because it takes a very long time, and there's an immense amount of risk and uncertainty in working with the government at scale. I think there's frankly no better time than now and the coming 5 to 10 years to do so. And that's really because of a lot of the changes that are being made within the department in terms of working with non-traditional companies and startups and really leveraging new business models to solve some of the modernization challenges that that the country has. So I think that creates an immense amount of opportunity for starting deep tech companies that are fundamentally dual use, that have both a commercial as well as a defense application to them, or even pure defense companies. Now is a fantastic time to be working in those areas.
Amazing overview, AJ. Something that we want to talk to you more about is really that partnership with the government, especially as it relates to all of the foreign policy and national security issues that we're going to talk more about with you. Talking specifically more about programs like SBIRs and STTRs and how the government can better support new companies and new startups that want to work in defense. What are the main issues with those programs today, and what needs to be improved so that it better serves not only the interests of startups, but also the interests of the American taxpayer and the interests of the country as a whole?
Sure. So the SBIR program as a whole, I think has some issues with the kind of types of companies that leverage a program. Obviously, it's a very large bucket of funding. Nationwide, it's billions of dollars on an annual basis. But I think what you see a lot is very, very small checks being written, and that makes it very difficult, especially for deep tech, hardware rich, capital intensive projects, to get across the so-called acquisition valley of death, from early R&D stages to an ongoing recurring revenue in a program of record. So it's, I don't think the SBIR program is kind of set up really to really require that. I don't know that the kind of commercialization metrics that are currently used, really, I think, evaluates commercialization performance sufficiently there. But all of the tools and pieces are there to leverage the program in a way where you're not sitting in it, like you're not building a company just to go after SBIR after SBIR. You're using it as kind of a means to an end. For us, our approach to SBIRs was number one, get a government contract, because once you get your first government contract, that starts to open up the next stages of things. And then, beyond that, the Strat5 program, which is, a larger chunk of dollars. So we signed a $30 million contract as part of a $60 million partnership with the Air Force. So that's basically a very large SBIR that's intended to drive, delivering a capability at the end of the day, and getting company prepared to move on to a program of record and say a phase 3. But you kind of have to approach it as a tool, not kind of the end all be all of what you're trying to build. Phase 1 and phase 2 SBIRs are in some cases comically easy to get. So I think in many cases, if you're going to a venture capitalist with hey, I've got like a bunch of phase 2 Cybers. That's actually probably like a negative signal, unless it's tied within a broader strategy of growth. Like, how are you going to graduate out of this program and eventually get to the point where you're getting to recurring revenue and you're in the essentially the country's budget. If that's the goal and there's a strategy where each of these Cybers are like playing a role in that strategy, that's a very different story, and that's the approach that we've taken at Hermeus. I don't think it's the normal approach, but I think it's really the way that the program should be leveraged. If part of the intent of the Cyber program is to attract private investment to come in alongside and actually deliver capability at the end of the day. I'd love to see a metric on Cybers that is like operational uses of technology that comes out of the program, both on the more so on the defense side than on the purely commercial side. So there are other barriers in there to companies working with the DoD. The budgeting cycle is probably the biggest one. I don't think there's actually an acquisition problem. I think all the tools are there from an acquisition standpoint. There's maybe a little bit of a cultural thing in terms of kind of management, middle management, especially kind of working with the tools that are there and available. But the 2-year cycle to get into your customer's budget is an incredibly daunting challenge for a startup that essentially raises funding for the next 18 to 24 months in and of itself. So like, you have to start early. You have to understand the physics of how the system works, and then you have to go in with the mindset that this entrance point is just that. It's not the end. It's just the beginning, and it's part of a greater strategy to grow what you're eventually delivering.
So, two quick follow-up questions to what you just said here, AJ. To what extent, you mentioned a lot of challenges that startups face when working with the government. To what extent are cost-plus contracts responsible to a lot of the issues that we have? I'm sure you saw this, but NASA Chief Bill Nelson said the other day how cost-plus contracts were a plague to the agency. And then, to solve all these issues, to what extent do we need the government to just, sort of change its mindset? Or do we need a lot of changes in legislation, acquisition processes, et cetera, et cetera?
Yeah, I think so. It was actually fantastic to hear Administrator Nelson, call that out specifically on the NASA side. I don't know if I would call it a plague, but cost type contracts certainly set up a very different and in some cases perverse set of incentives for a company. They're very, very comfortable in that, from the business's standpoint, you're not taking any risk. You're going to get paid for whatever work you do that's within scope for the contract, but you're not incentivized, to move with urgency, to deliver quickly, to accomplish more with less, since all of your compensation is tied to your costs. And like, at the end of the day, if you're looking at kind of like how venture companies are valued, like to get to a certain amount of kind of profit back to your shareholders. With a cost type contract, you're limited in the profit percentage. It's generally 8%, 10% ish. That means to get to the same amount of profit, your revenues have to be significantly larger than if you can deliver something with margins that are 20%, 30%, 40%. And at the end of the day, that's going to end up costing the customer, U.S. government and the U.S. taxpayer more than it otherwise should. So yeah, I'm a huge proponent of fixed price contracts throughout the development cycle. Frankly, I know like fixed price contracts for development where there's a lot of uncertainty. The DoD has been burned in many cases in the past, where small businesses have signed up for fixed price contracts and haven't been able to deliver. I think it works when it's paired with private capital that can kind of provide the financial capacitance, if you will, in the system, to enable you to work through on a fixed price type basis. So, I don't think they're appropriate for for every style of business, but for venture backed companies and other companies where private capital is is on the table to do what you need to do. Yeah, like fixed prices is the way to go. And then on your second question, kind of more to the is it a change in mindset that's required versus change in legislation? Like I said, I think it's on the acquisition side of the world. I think it is a change in mindset, not so much at the kind of top level leadership, but more kind of the day-to-day folks who are running the enterprise that is the DoD, from the contract officers and program managers, to actually be willing to take risk. There's an old adage that nobody ever got fired for picking Lockheed Martin, and that's probably true. But the incentive structure within the DoD, to see say a contracting officer get promoted for taking a risk, that's something culturally that doesn't typically happen. A contracting officer is probably going to get promoted if the GAO doesn't come in and mess with any of the contracts that they sign. So that kind of incentive structure, I think, is like the next step that needs to change, that kind of helps to solve some of the cultural elements that really kind of allow the folks inside the DoD on a day-to-day basis to use the tools that are available to them. I don't think the acquisition tools need to change. Middle tier acquisition, SBIRs, all these things, they're all there, and the authority there is granted by Congress. I think the place that legislation really needs to improve and change is more on the PPBE side, so planning, programming, budgeting, execution. So, as I mentioned before, a minimum 2-year cycle to get something into a customer's budget is incredibly difficult to deal with. And there's some small things I think that can change. Raising the reprogramming threshold and allowing budget owners within the DoD to kind of shuffle dollars around more easily, especially for innovation and kind of crossing the valley of death type programs as they're transitioning to programs of record. That's a huge knob that can turn. And I'll kind of give you an example about this. So, when the Air Force was, essentially preparing their budget for, fiscal year 23, Hermeus was probably like 12 people. By the time that budget made its way to Congress, essentially a year later, the company was, 60 people, and had, significantly de-risked the technical side of hypersonic aircraft, as well as raised $100 million. So much change happened so quickly in the startup world that just within the scope of like the Air Force setting its budget and Congress approving it, where like you can't make a lot of changes, it becomes very difficult to kind of impedance match between the two styles of business. So more tools, I think, that allow kind of flexibility in how budgets get allocated and expended is part of the way that I think some of the legislative pieces can help come into play and really accelerate the modernization enterprise within the department.
So AJ, tell us a little bit more on the side of primes, right? So we talked a little bit earlier around how your thesis that over time there's going to be more specialization, and we're not just going to have these large companies that build everything, but we're going to have more vertical specific like Hermeus. On the flip side, though, with the primes that are currently in existence, the Lockheeds, the Raytheons of the world, what are the good sides of those? What's it's always fun to critique the incumbent, but tell us the positives.
Yeah, I mean, I think when it comes to delivering exquisite capabilities that have to work, that you're willing to spend a lot of money on and willing to wait for, the primes they've kind of been built for that. They have the facilities that are necessary to do these things, not just from an R&D standpoint, but from a production standpoint. Whereas, in the startup world, we kind of have to build the team and build the machine that's building the machine, and then eventually build out the production capabilities down the road. Whereas a lot of that exists already on the prime side. So I think in terms of kind of like risk that is seen on the kind of non-traditional side that's maybe perceived as mitigated on the prime side is that kind of smooth transition to production. I think the primes also frankly understand how to work with the government a heck of a lot better than those of us who are coming in kind of new to this game. I think most folks who are kind of not used to working with the DoD or NASA or the U.S. government in general don't have a really good understanding of kind of the physics of the system, kind of how it all works, and that takes a good deal of time to understand. And in the meantime, the primes understand that really, really well. They're spread across the country. There's probably not a state that each of those primes that you listed don't touch in one way or another throughout their supply base, whether it's directly within their companies or through the subcontractors that they have in their contracts. And it's kind of an important part of the strategy when you're working with with the DoD or NASA or other parts of the U.S. government. And I think you've seen some kind of newer companies coming in and try to kind of play that game in a similar way. I mean, you can take a look at Blue Origin and their national team strategy for the lunar lander side, and I think sometimes you can overdo it. I think that was probably an instance where they went with a kind of a more difficult, more complex, maybe less optimal technical solution, and traded that for a better means of working with the government. Whereas I think SpaceX has kind of been able to pair both of those together quite well. But yeah, I think the average startup founder who's considering working at the DoD is probably like, I don't ever want to hire a lobbyist, and that's like, it's part of what you have to do, and and kind of get used to it. So yeah, I think that those are some things that that the primes are good at, and some of the ways they bring value.
So, AJ, taking this step back here and looking at the macro, do you think we're currently in a space race right now? How do you think both from within the US, general people feel about kind of the excitement around SpaceX and all of these other programs? Are we in that race?
I don't know if we're necessarily in one from a kind of a space standpoint. And, I'm a little bit removed from the kind of direct space world more so than I used to be, but certainly kind of still keep track of things. However, I think within the hypersonics world specifically, we're kind of in the midst of a kind of a techno-economic pursuit here, where we're kind of challenging our competitors across the Pacific Ocean, and I think that's gonna continue. It's going to continue for quite some time, and I think you're going to see it in other areas outside of hypersonics. I think if you kind of look at the list of defense modernization priorities, there's like 14 of them right now. Each of those, you could probably argue that we're in a quote unquote space race of sorts. And from a commercial perspective, at the end of the day, with say high speed aircraft, for example, whoever gets there first tends to get to write the rules. And obviously, it's quite important that we get to do that from a democratic perspective for the whole world. But so yeah, I don't know about space race specifically, but definitely in a lot of these other areas, there's definitely an urgency. I think that's palpable.
So a couple of questions following up on that issue. How worried are you specifically about the CCP? Where do you think we stand relative to the CCP, specifically when it comes to hypersonics? And then why does that matter? And why should people care? And do we think you need a new Sputnik moment for us to wake up to those challenges?
So let's see, a couple pieces there. So, I mean, you can kind of look at what's publicly available in terms of the progress that China has made in hypersonic weapons technology over the past couple of years. And it kind of takes looking a few decades back to kind of understand what happened there. Because I think if you looked at like the 90s and even the early to mid 2000s, the U.S. was still by far the leader in hypersonics technology, but we stopped. After the X-43 and X-51 programs, we really pulled back on our investments in hypersonics. And not only did we do that, we also published just about everything that we did in those programs. So kind of did everybody's homework for them. And then we decided like, hey, this technology is really not that important to us. Now in the span of say 10 years or so, China has basically looked at the technology and said, hey, this is a place where we can create an asymmetric military advantage over the West, kind of because they're kind of the away team when it comes to the Pacific. Like, this is our home ground, our home ocean. And they've got all these different, kind of high value centralized piece of equipment, whether it's, bases or aircraft carriers, targets against which hypersonic weapons can be incredibly effective. And, from our perspective, we had, if you kind of asked somebody in the DoD what hypersonic weapons would be used for 10, 15 years ago, they tell you, high value, time critical targets, things that move around. I think that answer is still true today, but I think the target set for those has expanded significantly because of the investments that the CCP has made in hypersonic weapons. So, they're obviously incredibly difficult to defend against. They fly relatively low in the atmosphere, so while they pop up pretty quickly on infrared, you can't see that far over the horizon, even with some space-based sensors. So they become very, very difficult to track, target, and defend against, which ends up imposing an immense amount of cost on somebody on the other side. So now not only are we spending money on hypersonic weapons development, we're also spending it on defense against hypersonic weapons, and they're really like coupled together. It's like I think a lot of folks have looked at some of the investments we've been making here in the United States in hypersonic weapons, and asking like, well, are we just doing this because Russia is doing it, because China is doing it? It's like because they have hypersonic weapons, so we have to have them too. I don't think that's actually the case. I think they have their reasons for having them. We have a different set of reasons for having them. That is partially driven by how we defend against those types of weapons. The best way to defend against the difficult to defend against weapon is to make sure that it doesn't launch and it doesn't know where to go. So I don't know if I want to say too much more than that, but there's different reasons why we're pursuing them relative to why other folks are pursuing them. So,
given all of this, AJ, how critical is it for the U.S. government to actually figure out hypersonics into the next decade? Give us a scenario, for the average person to understand. If we don't do that, what could happen? What is realistic?
If we kind of say, like, yeah, this isn't a technology that we need to invest in, I think we end up in a position where our forward bases and our assets that are especially like large naval assets will be able to be held at risk. And I think if you look at the Taiwan scenario, obviously a lot's being learned by what's going on between Russia and Ukraine right now. But the Taiwan scenario, the further and further away U.S. military assets, whether they're bases or things that are at certain bases that are maybe more at risk than others because of what hypersonic weapons can do, carriers, the further that those get pushed back, whether it's in the South China Sea, outside of the South China Sea, that kind of raises the likelihood that the CCP takes action in Taiwan. The harder it is for us to ensure that success is not blatantly obvious for them, because that's really what keeps conflict in general, military conflict, from happening. Somebody's not going to take action unless they have they're of the opinion that they'll win outright. I mean, you kind of look at what Russia did in Ukraine. Like, they went in thinking that they're going to be able to accomplish their objectives very, very quickly. It turns out they were wrong. So sometimes wrong assumptions come in, and then you end up with protracted conflicts, which are frankly the worst. But same kind of thing in Taiwan. So at that balance of power, on the naval side, on the air side, on the space side, starts to shift too far to the point where the CCP gets confident enough in their ability to successfully complete a fait accompli. The likelihood of that happening and that driving significant global conflict goes up. So back a little bit of a ways to when I talked about at the beginning about hypersonics being kind of a damping force. They're damping when there's kind of the success of them in achieving their goals is kind of not blatantly obvious, and that requires development on both sides. And that's not just weapons. Hypersonic aircraft play an immense role here as well in terms of kind of getting into the backfield and disrupting things ahead of using hypersonic weapons. So yeah, and I think a lot of people don't necessarily. I think it's understanding is growing, but the implications of something happening in Taiwan. We think supply chain challenges are difficult right now, and semiconductors are hard to get. The world will change significantly should something happen out there. So the ability of the United States and its allies to essentially continue to make it difficult for kind of decisive military action to be taken there is really what's going to prevent I think that type of event from happening.
So AJ, to bring it home for everybody, let's take a big step back. 2 questions for you. When you look at America today, 1, what keeps you up at night? And then 2, what keeps you optimistic in face of all of the challenges that we've talked about?
Yeah. So, what keeps me up at night? I think, obviously we have a country that is dealing with, an immense amount of political strife, on both ends of the aisle and the spectrum. that's being compounded by, in some cases, by external actors. And I think that unity is a big problem here, and that's probably the thing that keeps me up and worries me the most. It's really kind of our domestic situation. But the things that really make me optimistic are the willingness of people to unite together within smaller cohorts, whether they're companies or whatever, to really take on some of the challenges that are happening at a global scale. With it's almost like these David and Goliath, or Don Quixote going after windmills, things that most people would think are impossible. Like, that's so much the lifeblood of who we are as a nation. It has been ever since the country began, and I think those little things can inspire a much broader group of people to continue to follow behind that, and drive some of the unification that I think we need to see, to kind of allow us to sleep well at night. So, I think the future is immensely bright, and I think so much of that innovation and growth is not just going to happen in the digital world. It's going to happen in the real world. And obviously, it's going to be a pairing of software and hardware, but it's going to be solving problems that exist here in the real world. And of course, as an engineer, that gets me incredibly excited. But as an American, just seeing so many new frontiers that are out there to go be explored. Yeah, I can't think of a better time to go and do it.
Amazing.
An amazing note to kind of bring this home on. AJ, thank you so much for joining us on Village Global Solar Punk.
You bet. This has been great. Thanks, guys.